Welcome back to another special episode of Organic Chemistry, where today we decide which solvent is the best. So the rules for today are that we can only list chemicals that are common, and specifically we're talking about common solvents. And the properties that we're considering are for use as like a reaction solvent, for transferring material between vessels, for recrystallization, as well as for chromatography. So let's get started. So let's start with a nice simple one like ethanol. Ethanol has a boiling point of 78. It's somewhat polar, so it can dissolve some more polar molecules, and so it can be well suited to crystallization. Ethanol also has a reasonably low freezing point, so you can help crash stuff out of it relatively easily, but it's easy enough to remove if you have to use like a high vac or a rotovap, but it is still protic, so it's a little bit stubborn to remove with a rotovap. So I think ethanol gets a B tier. Now, if we're talking about like all of the properties of ethanol, I quite enjoy ethanol, so I think ethanol's S tier. But because we're just talking about properties as a solvent, we're going to put ethanol into B tier. Now, if we want to look at another one, why don't we look at THF? So THF has a boiling point of 66. It's also an ether, and it's actually relatively polar. If you've worked with diethyl ether but you haven't worked with THF, THF is actually quite good at dissolving complexes, metal-containing stuff. Maybe not like alkali metal salts, but lithium salts tend to be relatively soluble in THF. So THF is a pretty good solvent. Now it is miscible with water, which means if you're doing a workup and you're doing extractions, you're going to have some issues with it absorbing water, water absorbing it. So we can't give THF that high of a score, but it is pretty good. I still think THF probably belongs in B tier. Maybe THF belongs in A tier. We'll put it in A tier for now, and then we'll see how we do. So let's pick one that isn't going to get a very good rating, like carbon disulfide. So carbon disulfide is technically a solvent. Now, in most research labs, it's not used that frequently because it isn't very convenient to work with. Carbon disulfide has a boiling point of 46. It's also extremely toxic. However, it's one of the best solvents for dissolving sulfur, elemental sulfur. So because it's so toxic, it has a low boiling point, which is kind of nice. It can be used for Friedel-Crafts reactions, for instance. But it is relatively inconvenient to use because of how volatile it is. Now, we're not considering toxicity here, so I'm going to try and separate my bias. It's a little bit too volatile to do too much chemistry, but it can be used for Friedel-Crafts reactions. I'm going to put it in D tier. Okay, let's pick another one like dichloroethane. So dichloroethane has a decent boiling point. It's not too volatile, but it's not too non-volatile either, with a boiling point of 83. 83 is enough to do most chemical reactions. You might have recalled me saying in an earlier episode that most chemistry should be done below 100 degrees ideally. That's like a pretty good rule of thumb. So if you need to remove this on like a steam bath, you could do that. If you need to rotovap it, it's easily done. And now it isn't too polar, so that it doesn't have a lot going for it, but it isn't so non-polar either. Dichloroethane probably belongs in C tier, which is appropriate because there's chlorine in it. Now let's look at DMF. If you've ever worked with DMF, you know it's a real pain to get rid of. DMF has a really high boiling point of 153. Now, while that's unfortunate, it means you can heat reactions if you need to really get them going. So you can heat reactions in DMF overnight, and if it's sluggish, it'll go a little bit faster with heat. Now, it is a pain to remove. It is water soluble, though, so you can usually get it out with washes, and the last little bit of DMF that remains can usually be removed with column chromatography. So that's pretty good. I've seen DMF strip off the label from an NMR tube, like that white label that you have on an NMR tube, it literally dissolves in DMF, so that's like a pretty good solvent. And if you've ever tried dissolving stuff in DMF, it can usually dissolve salts. Now, the only thing that's taking it away from being ranked that high is it's pretty high boiling, which is actually like not a great property most of the time, because we want to use a solvent and then get rid of it. So I think really high boiling solvents are not too great, but pretty high boiling solvents are great. But when it's kind of like in the middle, it's not as great. So I'm going to put DMF in B tier because it's used a lot because it's really good. It's polar, but it's still a little bit annoying to get rid of every last bit. Nothing worse than when you see a proton NMR with a little bit of DMF in it. You're like, what are those peaks? It's like both of the methyl groups, and then the third peak is that CH. Now, ammonia. Ammonia is a great solvent for birch reductions. You can dissolve alkali metals, and that's pretty unique. However, it's pretty inconvenient to handle because you need to condense it to a low temperature, and you also need to like have a whole cylinder of that around, which is a little bit of a hazard, but we're only considering its dissolving properties. There's some very unique chemistry that can happen in liquid ammonia. And I mean, solvated electrons are like the coolest thing ever. If you haven't seen that, I'd encourage you to look into like sodium or lithium dissolved in liquid ammonia. Now, we don't use it that often anymore because we have so many other better solvents to choose from. So I'm going to put ammonia in F tier. If you disagree, you can comment down below. Now, kind of like THF, we have 2-methyl THF, which is occasionally seen in the research lab, but for the most part, this is used in industry. So industry loves 2-methyl THF. So while THF boils at 66, 2-methyl THF boils at 80, which gives it a little bit of extra oomph if you need to heat a reaction a bit higher. Additionally, while THF is somewhat miscible with water, 2-methyl THF is not. So that's a much better property. 2-methyl THF belongs in S tier. The only reason you don't see it used as frequently in research labs is just cost. I can tell you that personally. Now let's look at CO2. CO2 is a great solvent. It's used to decaffeinate coffee beans as well as other products such as tea containing caffeine. It's also used in the extraction of cannabinoids industrially. So CO2 is a good solvent. You can also make it supercritical, which is pretty awesome, but we're not ranking the most awesome chemicals here. We're just ranking how good they are as solvents. It's pretty polar, believe it or not. Now, the challenge is if you want to handle it as a liquid, you can't without very special apparatus. So that basically makes CO2 one of the worst solvents here. This gets to go in E tier. Now, pyridine. Older papers tend to use pyridine as a solvent. I have used pyridine as a solvent a handful of times, but it is such a pain to get rid of once you're done. It's got a boiling point of 115, but it is really stubborn to get rid of every last pyridine molecule from your flask. Typically, my strategy for getting rid of the last bit of pyridine is to put some toluene in there, rotovap the living daylights out of it at a decently high temp, and then just do that several times till all the pyridine's gone. So it's a good solvent. It's also fairly polar, but usually that's because it's also interacting with your reagents, if you're doing like an acylation, for instance. But it's a real pain to get rid of, so I'm going to put pyridine in F tier as a solvent. Now let's look at cyclohexane. Cyclohexane has been featured on our tier lists previously as one of the most toxic reagents, or perhaps it was on the best smelling but you shouldn't smell it reagents. Now cyclohexane has a boiling point of 81. It would be used probably more frequently if it wasn't as expensive as hexane, or if it wasn't more expensive than hexane rather. But it's miscible with some other solvents that hexane aren't. So for instance, you can mix acetonitrile and cyclohexane, but you can't do that with hexane and acetonitrile. And if I'm mistaken about that, then it's actually acetic acid I'm talking about. And acetic acid, I believe, is miscible with cyclohexane. So that's pretty awesome. Cyclohexane probably belongs in A tier because it's easy to remove. It's also a good chromatography solvent. Also very common for recrystallizations. Let's look at methanol. Now, despite its low boiling point of 65 degrees Celsius, methanol could be a real pain to get rid of in some reactions. Like if you're rotovapping stuff down, methanol, it's going to keep hydrogen bonding and it's going to bump a bunch of times. It's also a little bit annoying to get rid of if you're like trying to precipitate a salt from it. Now, other than that, it's relatively volatile, 65, so it's easier to get rid of. It's also relatively commonly used to do crystallizations and stuff. And because we're considering crystallizations, I'm going to weigh this a little bit higher than I otherwise would. I'm going to put methanol in B tier. Now, one of my favorite solvents is hexafluoroisopropanol. And if we are considering toxicity, this would massively tank its utility. But hexafluoroisopropanol is probably the best solvent that exists, in my opinion. I'm probably biased because I'm a fluorine chemist. But HFIP, it's able to dissolve proteins. It's able to dissolve amides that are usually fairly insoluble. With a little bit of crown ether, like potassium fluoride and other metal fluorides easily dissolve into hexafluoroisopropanol, and it's got a very low boiling point of 58 degrees. It also mediates several reactions as a solvent, so this is an amazing solvent. This is definitely S tier. If you've never tried a reaction with HFIP, you should. However, especially if you're female, you need to be careful working around HFIP because hexafluoroacetone is a teratogen. Now, that's not relevant to the tier list, but because I'm recommending it as a solvent, I feel morally obligated to disclose that. Now, let's look at chloroform. So chloroform is a pretty good solvent. It's slightly non-volatile-ish, like it's got a boiling point of 61. Now, it's also like an ozone depleter and a greenhouse gas, but we're only considering solubility here. It's actually pretty polar. It can be really good for chromatography if you've ever run into a challenging separation. It's worth trying like 70% chloroform hexane. Also, recrystallizations are frequently done with chloroform. And, deuterated chloroform for NMR, it's there like all the time. Chloroform probably deserves A tier, maybe even S tier, but I'm going to put it in A tier for now. Now, benzene. Benzene is another great solvent for crystallizations. It's got a lower freezing point of like 20-ish, which is not great, but it's got a decent boiling point of 80. Now, benzene dissolves basically everything, not quite everything, but pretty well everything. Uh, but, it's not too polar, so it doesn't dissolve some salts, some more polar reagents, but it's polar enough that usually you could even get like amines and amides to dissolve in benzene. So I'm going to put benzene in B tier, which is appropriate, B for benzene. Now, isopropanol also belongs in S tier, and let me tell you why. While it is very annoying to remove on a rotovap, it's not as bad as ethanol or methanol, but it's still annoying, even though it's got a higher boiling point of 83 degrees Celsius. Isopropanol is miscible with every solvent on most solvent miscibility charts. So you can take any of these solvents here, and it will be miscible with isopropanol. So that's pretty great. That's a really good solvent. Now, in addition to that, you can use it for chromatography, and so you can, because it's miscible with all these solvents, you can get whatever range of IPA with whatever solvent you want. So that's pretty powerful. It's also very common for recrystallizations, and it's volatile enough that you can get rid of it. So isopropanol is S tier. I still think hexafluoroisopropanol is better, but I would be terrified to run a column with hexafluoroisopropanol. Also, that would probably be super exothermic on the silica. Now let's look at acetone. Acetone is our savior. Acetone cleans our glassware. It removes the polish off of our nails. It's not as well suited as a solvent because it's fairly reactive usually, but when it's not reactive for chromatography, for instance, it's great. Now, because it's reactive, because it has CHs that can react with, electrophiles, it can act as a nucleophile, it can act as an electrophilic carbon. That's the only reason I'm going to put it in A tier instead of S tier, because it's a little bit of a liability under acidic or basic conditions or radical conditions, basically a lot of conditions. But we're going to put acetone in A, which is appropriate because A for acetone. Now, toluene. Toluene is a really good solvent. It's a little bit better than benzene because you can get it to a higher temperature of 111. Now, this is a little bit higher than we typically want for most reactions, but you can absolutely get rid of all of the toluene from a reaction. So even if it's a little bit annoying to get rid of, it's not the worst. Toluene's a good solvent. It's not too polar. It's like a little bit non-polar, but it's a relatively good solvent overall. Recrystallizations can be done with it, but it's not like the best solvent ever. I'm going to put toluene in A tier. Now let's look at DMSO. So DMSO is a good solvent. In fact, it's too good of a solvent. It's like the universal solvent. People say water is the universal solvent, but as I've said before, DMSO is definitely the universal solvent. So DMSO, really high boiling point of 190. However, you can partition it with water and extract from it with ether. And because DMSO is not miscible in ether, you can extract with ether. Now, it's kind of annoying because you get like tiny amounts of it in your ether, and if you don't do like a column, it'll still be there. You also can't really do recrystallizations from DMSO, or at least I haven't in my experience. You also can't really do a column with DMSO. So while it's a good solvent, it's not well suited for chromatography, it's not well suited for crystallizations, so I'm going to put DMSO in D tier. Now, xylene would be great, except it's always a mixture, which means if you have a little bit left, you have probably multiple peaks in your NMR, and depending on your vendor, it might be mixtures of different xylenes. You also have ethyl benzene in there usually. But you can get to a really high temperature. So the one thing this has going for it is you can get to a high temperature with it, and you can usually get rid of all of the xylene from a reaction. Now, in retrospect, I think the only reaction I've ever done with xylene is Lawson's thionations. Maybe I've tried some recrystallizations with xylene before to not much success. So I'm going to put xylene in E tier. Now, if we look at ethyl acetate, great solvent. Yes, it has an ester, so it would be sensitive under some cases, but it's like a pretty well-behaved molecule. It's used for almost all of our columns. It can also be used for recrystallizations. Ethyl acetate is 100% an S tier. If you're curious about its boiling point, ethyl acetate has a boiling point of approximately 77, which is not too bad. Now, acetonitrile is another really good solvent. I really like acetonitrile. It is a little bit more annoying to remove on the rotovap, but you can usually get rid of every last bit. Now, it's miscible with water, which means you can partition and extract from acetonitrile. You can also just concentrate down reactions fairly easily. Now, that nitrile has a lone pair that can like form complexes to inorganic stuff, so that's pretty good too. I think acetonitrile is A tier, boiling point of 82, or S tier rather, with a boiling point of 82. Now, dimethylcitamide, it's a little bit obscure. It's a little bit more annoying than DMF to remove because its boiling point is 165. It's polar. I mean, it dissolves stuff, but it's a little bit obscure. so I'm going to put it in F tier. Now we have pentane. Pentane is great. You can get rid of it very easily, but when you're running columns, the columns crack a lot, especially if you're doing mostly pentane. If you're doing like a pentane ether column, ether has a boiling point of 35, pentane has a boiling point of 36. It's, not great. It's great to remove, but it's not great for running columns, and because I have cracked columns before with pentane, pentane gets to go in C tier. But it is a good solvent, less toxic than hexane. Now, hexane is good, except it's a mixture of hexanes. So, some of them are going to come off first, some of them are going to come off later. And there's nothing worse than when you run an NMR and you see hexane peaks in it and you're hoping it's not grease. Now, hexane's great. We use it for most of our solvents for chromatography. Reactions can be done in hexane. We wash our mineral oil off with hexane. Its boiling point is around 70, but because there's a mixture, it's not as great. I'm going to put hexane in B tier. Now, MTBE, methyl tert butyl ether, MTBE, is a pretty good solvent with a boiling point of approximately, let me just check here. Methyl tert butyl ether has a boiling point of 55. So you can get it a little bit hotter than diethyl ether. It's fairly polar, so that's got, some stuff going for it. Easier to remove, preferred in industry for peroxide formation reasons, but that's not too pertinent to this video. Now, it isn't going to be too polar to dissolve superpolar stuff, but maybe that's what you want. I'm going to put it in B tier. I'm going to put ether in A tier, diethyl ether in A tier, only because I personally have used ether like a billion times for a billion reactions, including columns with hexanes. Ether is great. Ether almost belongs in S tier, but because it is a little bit too volatile, you can't get reactions as hot, so I'm going to exclude it from S tier. Now, dichloromethane is pretty close to ether in terms of utility. I love DCM. It's a fairly polar solvent. You can do a lot of chemistry in it. You can even get silver salts to dissolve in it sometimes. Again, good for chromatography, but not as well suited as ether. It just depends on conditions, obviously. DCM probably is an S tier solvent. Nitromethane, fairly polar, but it reacts with a lot of stuff. It's a good nucleophile because those CHs can easily be deprotonated. That nitro can also react with reductant, so it's not too well suited as a solvent in most cases. I mean, if you have a good enough electrophile, this could get alkylated, or whatever. So nitromethane, while it's kind of cool, it's a little bit too volatile. Not too volatile, actually, with a boiling point of about 100. So you can heat it. I'm going to put nitromethane in probably E tier. Now, acetic acid would be great, except it can sometimes be too acidic, so that's not as well suited. It's a good solvent, but most of the time you think of working with it in water, but when we do organic chemistry, we usually don't do chemistry in water if possible, or we try and get our product out of the water if possible. Acetic acid's good. It's a real pain to remove, though, because it hydrogen bonds to stuff. Now, the boiling point of acetic acid is 118, which is just like a little bit not that volatile. So I'm going to put acetic acid in probably E tier as well, just because it's annoying to get rid of. You can partition it into water, but if you're extracting with an organic solvent, since even like cyclohexane's miscible with it, you can start pulling some of that into the organic layer. It's not too great. Now, ethylene glycol, too polar, too annoying to get rid of, F tier. Now, water is the most important solvent for living organisms. It can dissolve salts, it can dissolve some organic molecules, but it's fairly well behaved. If you have something too greasy, water's like, no, I'm not going to dissolve you. You're going to stay separate from me. I wouldn't be here if it wasn't for water. So we're going to put water in S tier. Now we got 1,4-dioxane. 1,4-dioxane's pretty good. Got a boiling point of about 100 ish. And so 1,4-dioxane, it's good for like Grignard chemistry, LAH chemistry, stuff with metals. Yeah, you can usually get rid of it fairly easily by rotovap. It's not too hard to get rid of every last bit of it. It's somewhere between polar and non-polar, so it's pretty good. I think 1,4-dioxane is probably an A tier. Now, it does form peroxides, but that's not pertinent in this episode. Carbon tetrachloride, it's a very good non-polar solvent. If you're going to do radical chemistry or halogenations, for instance, you can do that in carbon tet, and it's already fully chlorinated, so you don't have to worry too much about, chlorine chlorinating it further if you're doing a chlorination. Now, it's toxic. That's not too pertinent, though, and it can react with some nucleophiles, such as like phosphines. Like it can pull off a Cl+, because this is kind of like a weak chlorine donor, but it's also not polar enough to dissolve too many chemicals. So I'm going to put carbon tet at like probably D or an E. Let's put it in D. Now, heptane has a slightly higher boiling point than hexane. Now that could be a good thing or a bad thing because heptane has a boiling point of 98. It's also, used quite frequently in industry, so I'm going to put it in B tier along with hexane. Trifluoroethanol. Trifluoroethanol has a boiling point of 78. It's a good hydrogen bond donor, kind of like hexafluoride isopropanol is, but it's a little bit worse. Most of the time, HFIP will win over TFE, but occasionally TFE wins. Now, it's not like anyone's first choice as a solvent, because if there's any of this left, it's going to contaminate your NMR. Yes, you could get rid of it by chromatography relatively easily, but it's kind of like a little bit inconvenient, so I'm going to put it in E tier. Now, last but not least, we have GLIME, dimethoxyethane. This is kind of like a mini crown ether. It can coordinate certain transition metals. It can also bind to some polar molecules fairly well. It can be very easily removed by rotovap, and it's just like an overall decent solvent. It's probably not as good as 1,4-dioxane, but it's a pretty decent solvent. I'm going to put this in C tier. So hopefully you've enjoyed this lecture, this video ranking all of the solvents. If you have any comments, you can comment down below. I left out some chemicals because this is already a fairly extensive list, but hopefully you found this entertaining and hopefully a little bit educational. It would really help out the channel if you left a like and subscribe, and I hope you have a great day.